Okay, so number one, remember we are going to, the power is going to go by 1. We're going to divide by that new power. That's what happens to each. Please don't forget, if there's a constant on there, the constant is going to just hang out and enjoy the ride. 9 is plus 9x. You got to put that x on there. Don't forget your plus c if you're evaluating an indefinite integral. If there's no boundaries, please just put the plus c. So our second one here is 2 cosine of x minus 3 sine of x. Now, if you're going backwards from a cosine back to a sine, you don't have to change the sign, because the sine of x, the derivative is cosine of x. So the antiderivative of a cosine of x is a sine of x. But the sign here will change sign when you go backwards. So that's going to become a plus 3 cosine of x plus c. How could we check the answers for 1 and 2? Take the derivative. If you take the derivative of this, take 3 seconds and check your work. You can probably do those derivatives in your head. The derivative of that is 2/3 times 3x squared, which is 2x squared. The derivative of that is 10x squared divided by 2, which is, no, it would be 10x divided by 2, which is 5x, and so on. So feel free to check your work by doing the derivatives. Okay, let's do another one. Now, if you happen to have boundaries on it, we don't need the c, because if we plugged in the upper bounds, we would get a positive c, and if we plugged in the lower bounds, we would get a negative c. So the c's are going to cancel each other out. So they're not necessary when you're dealing with the bounded integrals. Now, if you stick in the c, it doesn't hurt a darn thing. Just one will be a plus and one will be a minus. They'll cancel each other out. But so what you're going to do here is same thing as we did before, antiderivatives. So our power is going to go up by 1, divide by the new power. Power is going to go up by 1. You can divide by 1. That's the new power if you have the urge. And then put a little marker on the side to show what your boundaries are. Now remember, it's always upper bound minus lower bound. So that will help you with the next phase of things. Okay. So now when we stick in our upper bound, that would be 1/3 plus 4, minus when we stick in our lower bounds, which would be 0/3 plus 0, which is 0. So it's going to be 13/3. Don't always assume that plugging in 0 is going to result in an answer of 0, because it doesn't always work that way. Okay, so don't always assume that, just so you're aware. Do we have any questions on the basics? Do you have any questions on those ones?
Oh, that's the basics?
Yeah, do you know that? No, it's not. Okay, so next, we're going to integrate using u-subtitution. Okay, so first off, let me give you some where I'm going to give you what the u is, you know what I mean? So the first few on the quiz, I will say, using a u of, you know, okay. So let's do, we're going to integrate from 0 to the square root of pi x cosine of x squared dx. And our u is x squared. So I'm going to give you 2 of them where I'm going to give you what the u should be. And then I'm going to give you 2 where you have to decide what is the function that's stuck, what is the u going to be, okay? So if u is x squared, remember the procedure. We want all of the x's and dx's in the problem to go away and be substituted in with u's. Now we already know what this is, so this is going to be u, but we do have to know what is x dx equivalent to, so we can substitute something in for that. Well, if we do the derivative, du dx is 2x. Now remember, we are trying to sub in all the other x's in the problem. All the other x's will be x and dx. So we want to get one side of this equation to say x dx. We want to get everything else to the other side. So we're going to take the 2 to the other side and turn it into a 1/2. We're going to get the x and the dx by themselves. So now we know the substitution. The substitution, where we had the x dx, we're going to replace it with its equivalent 1/2 du. So ignore your boundaries. I'm not even going to write the boundaries right at the moment. And I'm going to put 1/2 du there, and then the cosine of u. Now, we're ready to do derivatives just like we did in part 1. You're just going to take the antiderivative of a cosine. The 1/2 just sticks along for the ride. So that's sine of u. Don't put the plus c. We do have boundaries coming. Now, let's stick our u back in terms of x's, and then we'll write our boundaries down. So that's 1/2 the sine of x squared, and our boundaries are 0 and the square root of pi. Now let's plug in our boundaries. That's 1/2 the sine of our upper bound. Well, if I square a square root that's on the pi, I'm just going to be left with a pi, minus 1/2 when I plug in 0. Now you have to remember what's happening on the unit circle. What is the sine of pi? What is the sine of 0? The sine of pi and the sine of 0 are both 0. So this is 0 minus 0, or 0. Now that doesn't happen very often, but the area must cancel each other out, I'm assuming. Okay. So that's one where I've given you the substitution. Do we have any questions about that one? Okay, let's do another one where I've given you what the u is. Let's let our u equal x squared plus let's go 2x squared plus 4. And our integral is 2x times 2x squared plus 4 to the 5th power. Okay. So we know what the u is for this one. So if we know what the u is, that's going to be this right here. That's where the u is going to be. So we need to know what is 2x dx equal to, because 2x dx is the only other things left in the problem. So we're going to take the derivative of this, which is 4x. Now it's not 2x, but if I multiply both sides by half, 1/2 du is equal to 2x dx. So I can substitute in 2x dx and replace it perfectly with a 1/2 du. So I'm going to have a 1/2 and a du. That's going to be the sub for that. And then it would be u to the 5th power. Now, there are no boundaries here, so make sure to put your plus c on your final answer. Now, we're going to take our power is going to go up by 1. We're going to divide by that new power, plus c. Now, your answer is not complete until the x's go back in. Remember, u was equal to 2x squared plus 4. So we can take the 1/2 times this, the 6 that's there, and let's just put that over 12. And then it's going to be that u value, 2x squared plus 4 to the 6th power plus c. Now, how can we check our work? We could take the derivative of this. We should get the function that's on the inside, or you didn't do it right. Any questions about that one? Okay, let's do another one. Now, there are 2 on the quiz tomorrow that ask us to discover what the u is before we begin. So let's say we have that for a problem. Now in this one, I have not given you what the u is you're going to use in your u substitution. Can anybody tell me what is stuck somewhere inside of something, which is a good candidate for our u? Yes. Exactly. So our u is going to be x squared plus 3. So there'll be a little line for you to put what that u is that you're going to use in the problem. Okay. And now we're going to do the du dx. So du dx is equal to 2x. Now let's go back in our problem. This is ready to go. That's u. We need a 2x dx to substitute in. So the 2x is actually perfect, but let's put the dx over with it. So then that tells us that du is going to come into the problem where 2x dx was sitting. Now, if you went to do the derivative of this, one of the things I would have told you is it's probably better to write it like that. So some of those rewrites are still essential. Square roots make them 1/2 powers. Things that are in your denominator make them negative powers. So now let's go ahead and do the substitution. So 2x dx just comes out and leaves a du behind. This is a u to the -4. So it's actually a pretty straightforward integration from here. Here's the part you guys mess up. If the power goes up by 1 and your power was -4, what is -4 plus 1? -3. You guys want to go to -5, which is incorrect. So you want to make that -3 and then divide by that new power. If there is a fraction already there, just multiply your denominator by that new power. And now we got to stick our u's back in. Now remember, our u is equal to x squared plus 3. So that would be x squared plus 3 to the -3 over -3 plus c. Now customarily, you should put the negative out in the front. It shouldn't be in your final answer in the bottom. So you can write your answer like this. You could also write your answer as that. So I'll accept this one or this one as your final answer. Okay, any questions about that one? Okay, let's do another one where we have to figure out what the u was. Oh, let's see here. I'm just trying to make up a problem for you. Oh, let's do that one. Can anyone tell me what appears to be stuck? 1 plus 7x, that's right. Now, the only thing left in the problem is a dx, because if we stick the u in there, the only other x in the problem is a dx. So we just have to do the derivative and see what happens. Well, we get that du dx is equal to 7. There's not a 7 on the outside of that quantity, so we need to move the 7 to the other side, and the trick, as you've seen over and over, is 1/7. So now dx can be replaced with a 1/7. But remember, I would suggest rewriting the cube root as a fractional exponent. Can anybody tell me what that fractional exponent is? What you got, Barry?
1/3.
So that's a 1/3. Okay, so let's put all our u's into the problem. We are going to get u to the 1/3 du 1/7 on the outside. So dx is equal to 1/7, so we have to include that. And now it's just an integration. The 1/7 hangs out. The u goes up by 1. 1/3 plus 1 is 1/3 plus 3/3, or 4/3. To divide by that new power, just multiply by its reciprocal. Now I'm going to put the boundaries, but I'm going to put that those are x's to remind you, you can't plug them in yet unless you would change the boundaries to use, which is possible. It's not hard to do that. The upper boundary would be 8 and the lower boundary would be 1. You could do that. But let's just go ahead and put the x's back in. I'm going to do it over here so you can see it. So we get 3/28, 1 plus 7x to the 4/3, and we're going to plug in 0 and 1. Okay, if I plug in 1, I get 8. So I get 3/28, 8 to the 4/3, minus 3/28, 1 to the 4/3. Okay, the cube root of 8 is 2, so 4/3 just means take the cube root, get 2, and then take it to the 4th power. So it becomes 16. So that's 3 times 16/28. I'm going to fix it in a minute. And then 1 to any power is just 1, so that's 3/28. 3 times 16 is 48, so that's 48/28 minus 3/28, which is 45/28. Now 28 is divisible by 7 and 4, which have no common factors with 45. That's your answer. Just leave it. Okay, so that is our final answer there. Anybody have any questions about that one? Yeah, definitely. We'll do one more. And then I think we're good to go, hopefully. Everybody got what they need there? We good with that one? Okay, let's look at number 8. So here's our problem. We're going to integrate z squared over the cube root of 1 plus z to the 3rd. Sorry about that. And then we've got, we have to pick our u, and we got to integrate and all that stuff. Okay. I would suggest rewriting this to be z squared times 1 plus z cubed to the negative 1/3. That's a dz. That should be a dz. Before you get started. So do a rewrite to make your life a little easier. Anybody see what's stuck? What's stuck? What's stuck? What's stuck? 1 plus z cubed. Now, remember, that's going to go right here. That's our u. So the other things that need subbed out are z squared dz. So we've got to find out, what is d squared dz equal to? Well, if we do our integration, du dz is equal to 3z squared. So we don't have a 3 in there, so that means take the 3 to the other side, get the z squared dz by itself, because that's what we have to sub in. Z squared dz is what's in the problem, so we're going to take that out. We're going to replace it with 1/3 du. So we're going to do a 1/3 out in front, du in the back. We have a u to the negative 1/3. Everybody understand how we got that far? Okay, now we're just going to use, oh, okay, thank you. So now we're just going to, okay, so now we are going to integrate. When we integrate, there are no boundaries, so we are going to put a plus c on this problem. The 1/3 is going to hang out there for the ride. Negative 1/3 plus 1 is negative 1/3 plus 3/3, or 2/3. So our power is going to be 2/3. We have to divide by 2/3, which is the same as multiplying by 3/2. The 3's cancel in front. We are left with 1/2. Remember, we know that u comes out, and we know that's equivalent to 1 plus z cubed. And that's it. That is your answer. And there you go. So please turn that in where you see 5355 quiz review.